Welcome to section 5.1 about exponential functions. We're going to start with this interesting fact right here that 2 to the 10th is going to be approximately 10 to the 3rd. Really interesting fact that we can use with all of our problems now. So the first problem says estimate 2 to the 40th in terms of a power of 10. It's not asking us what is 2 to the 40th. It wants us to rewrite it with a base of 10. So I'm going to start with my known fact that 2 to the 10th is equal to 10 to the 3rd. But now I want the exponent to be 40, 2 to the 40th, which means I can multiply both sides by a power of 4 in order to get the left side to be 2 to the 40th. I know a exponent raised to another power is when you multiply, so I'll get 2 to the 40th on the left. Same thing on the right. 3 is being raised to the 4th power, so you multiply, and I just rewrote 2 to the 40th in terms of a power of 10. Second example, estimate the power to which 10 must be raised to yield 2. In other words, to equal 2. So just like before, I'm going to start with my known fact. And this time, I want the left side to just be 2. That means I'm going to have to raise both sides to a power in order to cancel out that 10. That's the exponent. Well, in order to get rid of that 10, I'm going to multiply by 1/10 in the exponent, because a power to a power is multiplication. So now I'll get the left side to just be 2, because 10 times 1/10 is 1. It goes away. And the right side, 10 is raised to the 3/10 power. So it's asking what power in which 10 must be raised. Well, it must be raised to the 3/10 power in order to get the left side to equal 2. Couple exponent rules coming at you. Hopefully this is review. If it's not, please make sure to listen carefully. When you have two like bases, if you have a like base being multiplied, you will add your exponents. So whatever A is, add it to B. If you have like bases that are being divided, you're going to take your base and you're going to subtract your exponents. We already reviewed the power to a power rule. All it is means you multiply A times B. Multiply your powers. You might see something where there's parentheses, x minus y raised to a certain power. Well, all it's saying is that x is raised to that power, as well as y is raised to that power as they're being divided. If you have x times y both raised to an exponent, then both individually are raised to that exponent being multiplied together. Fun fact is x to the 0 or anything to the 0 power is always 1. Now we're going to simplify expressions containing some irrational exponents. Irrational really just means square root or a cube root, or any kind of root is irrational. We're going to use our rules from above and try to simplify. So example 3, I see 3 is raised to the root 2. That whole product is raised to root 2 as well. Well, I know based on my rule about a power to a power right here, I just multiply. So I'm going to do 3 root 2 times root 2. That's what a power to a power represents. Root 2 times root 2 is just 2. 3 squared is 9. Always simplify as much as possible. In this case, all the way to 9. Example 4 looks pretty similar, except for there's now not a square root of 2 that is being raised to. So really, I have 3 raised to the 2 times root 2. And notice I switched that order. It will not matter with multiplication, but the reason why I did this is because I know what 3 squared is. 3 squared from the problem before, and just because you know 3 squared, is 9 raised to the root 2. This is as simple as you can get. You can rearrange that exponent multiplication in order for you to have a simplified answer. We also could solve something with an unknown exponent, which is example 5. When you have an unknown exponent, there is a very nice rule that we can use. The fact is, if you have equal bases, so if your bases are equal, then that means you're going to have equal exponents. In other words, if I can rewrite 4x equals 8 to have the same base, then whatever those exponents are, they'll be equal. So I'm going to try to go as small as possible. We always want the smallest base. It'll make it much easier. So when I think of 4, I realize I can rewrite 4 as 2 squared. Yes, there's an x there, so make sure you don't forget, because I'm just rewriting 4, and there's that power of x. And I notice I can rewrite the right side as 2 cubed. 8 is equivalent to 2 cubed. Well, now look, I have my equal bases, which implies my exponents are equal. So that's telling me that 2x will equal 3. I just take those exponents, set them equal. X would be 3/2, and you just solved the equation. Moving on to sketching. So, sketching of exponentials, as always, I'm a big fan of XY tables, but there are some interesting facts that we want to look at besides just the XY table. For example, when you look here, notice y equals 2x, this curve right here, and it's also right here, is always going to be positive. Always, always, always. Note on the bottom, y equals 2x is always positive. The reason being, if I try to do any XY table, oops, don't want that. If I'm trying an XY table for y equals 2 to the x, here's my x, here's my y. If I plug in 0, well, we know that anything raised to 0 power is 1. If I plug in 1, 2 to the first is 1. Plug in 2, 2 to the squared is 4. So realize it's going to keep going up. Oh, I apologize, that should have been a 2. It's 2 to the first, and then 2 to the fourth. So you notice it's going to keep going up as the curve. But what if I chose a negative value? What if I chose -1? Well, that is y equals 2 to the negative first. You don't leave a negative exponent in your answer. You flip it to the bottom and make it positive. So really, if I plug in -1, I just get 1/2. I'm not at 0. I'm not even close to it. I'm at a half. If I plug in -2, again, you can't leave a negative exponent, so you bring it to the bottom, make it positive, realize that's 1/4. So you are getting smaller, 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 but you will actually hit an asymptote at this line right here, y equals 0. You will never cross it. Then I compare some other functions to it. What if I, for the first example, made it -2 raised to the x? Notice that's the pink. It just reflects over the x-axis. There's not going to be an x-intercept, again, because of that horizontal asymptote. it will have the y-intercept of -1 versus +1. And that's pretty much the big difference. We also could have it where the negative sign is in the exponent. Well, what happens in this case is that it reflects over the y-axis. It can be written as either way. I prefer not having a negative in the exponent. It's actually very improper. So if you want to rewrite it as 1/2 raised to the x power, that is great. Notice again, it won't have any x-intercept because of that horizontal asymptote. Last example for you. Knowing the fact that x squared is always positive, right? From above with the graph, you can see that. Since it's always positive, we can solve this equation using that fact. So first thing I'm going to do is notice it's in both terms here, so I can factor it out. I can do a nice GCF action. Take the 2x out. What's left over would be x cubed minus 3, and that equals 0. I have a nice product that equals 0, so a nice zero product property. I can set 2x equal to 0 and set the next term equal to 0. Right off the bat, I know this left equation will not work. Not possible. Because of the fact we just learned. 2x needs to be greater than 0. It's positive. The equation on the right, I can solve that. I can add 3 to both sides. I need to undo the power of 3. So like we did at the beginning of the notes, you can choose to raise it to the 1/3 power on both sides. You could also take the cube root of both sides. Both are completely okay. It's your preference. I get x by itself over here. If I typed the cube root of 3, or 3 raised to the 1/3 power, I would get about 1.44. So the only way we knew how to do this is because we knew 2 to the x is positive. If you have questions, I will answer them during class. Go ahead and attempt your homework. Good luck!